All right, so our goal in these problems is to find the absolute extrema for these functions. And what that means is to find the maximum and or minimum. So the highest or largest y values and or the smallest or lowest y values. So let's look at this first one. So when you're trying to find extrema, maximums or minimums, you essentially want to figure out critical values, and you do that by determining where the derivative is undefined or where it's equal to 0. So let's first calculate the derivative equation. So f prime of x will be 2x plus 5. And then we set this equation equal to 0. So f prime of x equal to 0. So we find where is this equation satisfied. So it's 0 equals 2x plus 5. So take away 5 divided by 2. That means x will be -5 halves. So this is one critical value. Now, we call this a critical value because that means that at this point, there could be a minimum or maximum. Something's going on there. It could be nothing. It could be neither. But let's see what's going on here. And since we have a closed interval, we also want to test what the values are at the endpoints. So we want to essentially find the values of the function at -4, at -5 halves, and at 0. So we just evaluate these and then compare them, and the smallest one will be our minima, and our biggest one will be our maximum. So evaluating f of -4, so we evaluate it by plugging it into the original function. So you get -4 squared, so 16 plus 5 times -4, so 16 minus 20. You're gonna get -4. Next we plug in -5 halves. We get 25 fourths minus 25 halves. And that'll be -6.25. And plug in 0, you always get 0 plus 0 in here. You get 0. And so this is our lowest value. So this is going to be our minimum. So our minimum occurs at -5 halves, comma, -6.25. And this is our largest value. And so this will be our maximum. So our maximum will be at 0, 0. It's really that simple. So let's go ahead, let's do another one. So here we have the function f of x equals the square root of x minus 2. So we want to see where the possible maximum and minimum are. So again, we find the derivative, f prime of x. Remember, this is the same as x to the 1/2, so we use the power rule. So f prime of x will be 1/2 times x to the -1/2 minus 0, or just, doesn't matter. And then we find where is this derivative equal to 0, or where is it undefined? So f prime of x equals 0. So where is 0 equal to 1/2 x to the -1/2? Now this will be, 0 at 0. So, x will be 0. This will be 0 when x is 0. That's one of our critical values. But also, well, actually, no. That's not what I meant. This is going to be, let me rewrite this as, let's rewrite the function as, I don't want to make that confusion. It's still a critical value, but for a different reason. So this is 1/2 times, the square root of x. So the -1/2 power, move it into the denominator. So it's going to be a critical value because it's undefined for x equals 0. Because you plug 0 into there, you're going to have 1/0. So where you want to check this, and you want to check the endpoints. Now, there's, the endpoint, we go at 0. So we have the same value here. And so we really just have to check f of 0 and f of 4. Because coincidentally, 0 is the same as the interval, or the endpoint of the interval. So we see what f of 0 is. F of 0 will be the square root of 0 minus 2. So 0 minus 2, so you'll get -2. F of 4, square root of 4, which is 2. 2 minus 2 will be 0. And so then this will be your minimum. Your minimum will be at 0, -2. And this will be your maximum. The maximum will be at 0, 0. Let's do one more. We have f of x is 4x over x squared plus 9. So again, let's find the derivative. And for this, we're going to use the the quotient rule. So, it's kind of tedious, but we got to do it sometimes. So quotient rule, the derivative of the top, 4 times the bottom function, times x squared plus 9 minus the top function, so minus 4x, times the derivative of the bottom, which will be 2x, all over the bottom function squared. So all over x squared plus 9 to the second power. And so let's reduce this. So let's go to 4x squared plus 36 minus 8x squared. And then you'll get -4x squared plus 36 over x squared plus 9 second power. So let's find where this is undefined and where it's going to be 0. So f prime of x will be 0. Essentially, we just set the numerator equal to 0. So we solve for the 0 of -4x squared plus 36. Take away 36 and divide by -4. So you get -36 over -4 equals x squared. So you get 9 equals x squared. And then x will be positive or -3. Have x1 be 3 and another one be -3. So we want to test these. These are our critical values. And then, it's undefined when the denominator equals 0. So if you can make x squared plus 9 equals 0. And this is nowhere. So there's no undefined values. So these will be our critical values. Critical values. So we just want to test what the function values are at -3, +3, and at the endpoint, so -4 and 4. And then let's compare them. So let's go in order. -4, f of -3, f of 3, and f of 4. All right, so plug -4 into the function. So -16 over 16 plus 9. So 25. Plug in -16 over 25. Plug in -3. Plug in -12 over 9 plus 9. -12 over 18. Plug in 3. 4 times 3, so 12 over 9 plus 9. 12 over 18. And here you'll get 4 times 4, so 16 over 16 plus 9 again. So 16 over 25. And then so we just look at what these values, which of these values are, how these compare, which one's the biggest and which one's the smallest. So we can reduce this into, divide that by into 6. This will be the same as negative 2/3. Let's be positive 2/3. Now you can rewrite them as decimals if you want, but this will be your smallest value. So this will be your minimum, and then this will be your maximum. Maximum. And you know, you're good. It's all you gotta do because you already found them, and it happens to be like a what do you call it, an even function. So that's why they happen to be like opposites of each other. So that's all there is to it.